Hello everyone, and welcome to part 4 of my raylib Asteroids miniseries. At this point, it feels like we've got the main systems of the game in place. We can turn the player, we can shoot the asteroids and they will split off, we can move around, but we don't seem to have any other interactions between the players and the asteroids, so I don't seem to be taking any damage from them. We also don't have a score, so we don't really get any reward for breaking these asteroids other than the fact that they look kind of neat when they split. But it's, as I said, the main thing that we're missing at this point is real game state. So we need a score, we're going to need some kind of health or lives system. Before we get into what we're going to add today, I just want to quickly go over a couple of the small tweaks I made off camera. So I turned down the debug menu significantly. I decided to go with the checkbox approach instead of the buttons along the side. This is more scalable. I added a combo box here so that we can cycle through the different angle views. So the first one will show the new asteroid angles like it did before. I have it so that it chooses a color based on how many cones there are on the screen, and I have the cones fading out after a certain amount of time. I can choose to show the split asteroid angles instead. So these are the angles of the asteroids when they are destroyed. Originally I had it so they just chose a completely random angle, but I found that it was kind of unfair when you would blast an asteroid and it would continue moving straight for you. Again, all things we can tweak in many different ways. There's one more value for the combo box, which is to just show all the angles. So, probably a pretty loud way to play the game. I don't think most of the time I'm going to want to play it like this, but it's just enjoying the fact that it's really easy to create these kind of debug visualizations. When it came time to add logic for the asteroids and projectiles, I made the choice to separate the definition of the types involved. So here's asteroid and here's projectile. Those are separated from the game specific logic. So being able to spawn projectiles, update all of them. So anything that works on the game list, which are these three here, same thing goes for asteroid, anything that works on the asteroids themselves, but then things that work on an individual asteroid are in their own files. I'm probably going to want to continue this pattern for the remainder of the game logic. So although these files are going to seem small at first, I'm just going to keep piecing them out. I've added a game score and game player file. For something like score, this can probably be very simple. We can create a function called add points. We can add a void function to draw the score. And we can add a function to reset the score when the game is reset. Inside gamescore.c, I'll need raylib and constants. I can create a static int called score. Reset score will just set it to 0, and add score can just increment that value. For draw score, I'm just going to format some text to have the number followed by points. I'll need to measure that text so I can determine where the text is going to be, and just for a little pizzazz, I'm going to throw a shadow on the text. Hopefully that will help readability whenever the player or the asteroids are behind it. It's probably worthwhile to fade these colors. This way the character is at least always a little bit visible behind them. And to avoid doing this fade calculation every single time we want to draw the score, I'll just make those constants as well. It's generally a good idea to avoid using magic numbers in your code, especially when you're doing graphical stuff like that. Some people might not like the look of having 6 const fields at the top of a function, but for me, it makes everything seem more readable and I really don't have a problem. So we can see that projectiles is borrowing from game asteroids, and in the same way, game asteroids is going to need to borrow from game score. When we destroy an asteroid, we're going to want to award points, and we can actually use this switch statement to help us decide on the value. In this case, because we have an expression that can determine the points, I'm not going to use the switch statement, but this is a good example of where we could do something like this. So like I said, I know I can just multiply 10 by the size and I'll get what I want, but remember what we were saying about magic numbers. I still don't really think it's a good idea to just have the magic number, so I'll create this asteroid base score instead. Also, when I was adding the asteroid splitting logic, I didn't do my due diligence and make these constants as well, so I'll fix that. The only real exception I have to magic numbers is if you're going to use something like 0 or -1, I think it's generally pretty self-explanatory, though I have seen constants for invalid time and constants for invalid index. When we destroy an asteroid, we determine how many points we are going to add based on the asteroid base score and the asteroid size. And at the end of the function, we add the score. Testing it, the score is definitely working, though I am going to just remove this font size plus from the Y. While I was at it, I also decided to make it so that drawing the number and drawing the word points are actually different elements. This way I can control the font size and position separately. To do that, I just separated formatting the number into a text from the points, measure those separately, and then I can do a little bit of math magic. You can pause here if you want to check out exactly what it is. At this point, we're worrying a little too much about how it looks, because the truth is, I just don't have the artistic ability to make it look excellent. I mean, just that ship sprite alone took me forever to make, so I don't want to spend any more time on how it looks for now. The important thing is the scoring is working, but we don't like the way the projectiles work. They are still hitting the asteroids off screen, and we don't want that. In projectile, I will include the constants. I'm going to define this screen area rectangle, and I'm going to add an OR case to this, disabling the projectile and returning false. Basically, all this is going to do, we're going to check if the projectile is colliding with the screen area, which really means if I put a not on it, if the projectile has left the screen, then we'll just disable it. So now we can see, even if I camp a triangle until it goes off screen, I will not be able to shoot it anymore. The next problem that we have is when we say player draw, that's something from within the player file. We pass in the player and the texture, and from the update draw frame, we also like to pass the player in for the player update. Now, I did create a game player C&H file because we're going to need to move this player out of here. Having the player and the texture in here, these are the only static fields inside of main.c, which, I'm going to go ahead and give myself a pat on the back here, because usually by this point in a prototype, I have dozens of static fields still in the main file. So the loading of the player and the initialization, that's all going to go into one method that we can call after init window. And then we're going to be able to just say update player instead of player update, and say draw player instead of player draw. I think the idea that I was having was that since we can't have member functions, I should name any function pertaining to a specific struct with the name of the struct, but I don't think I did that across the board. So here we have asteroid update, asteroid draw, asteroid radius, those are good, but then I have create asteroid. Looking at projectile, same problem. So I'm inconsistent, but I'm consistent in the way that I'm inconsistent, and that's got to be worth something. I really don't like this warning here. It's because we're not using this value. At some point, I was intending to add it to show debug visualizations, and I never got around to it. So to get rid of this warning, because it's kind of breaking my heart, I'm going to quickly add that. Now that I think about it, adding this visualization was actually really useful because now we can see that a projectile despawns the second it goes off the screen. Now there's no warnings in the update draw frame function, which we love to see. Now that the player is being managed by its own file, we can feel free to add more functionality to the player's interaction with the world without worrying about bloating the main file. Now I was expressing that I was worried about how I could rename this function, and the truth is, there's going to be a lot of other update logic in this function aside from this, and all this really does is move the player, so that can be the name. So once we've moved the player, now we can try and do a check against asteroids. Now I want to make it clear that if you have hundreds of objects in your game, you can't just put them all in one bucket and try to have the player collide against all of them. It doesn't really make sense. In the case of our game, the player is a pretty small object, and if the screen was huge and we had the capacity to have lots of objects, even just on screen, anything we can do to reduce the number of objects we're checking is very good. In a future video, I may try to implement a quad tree, which is a great example of how in a 2D game, we can organize our objects so that objects that are far away and can't possibly collide, we don't need to consider anymore. For now, I am just going to go ahead and include the asteroids file. I'm just going to do all the logic in here, and I'm just going to grab the array directly. As I said, is not a great pattern. As we've done several times before, it's really easy to loop over all of the asteroids. I can just get the asteroids array from this function. I know that the max is asteroid max, and I can create a loop. Generally, I like to grab a reference to the specific element that we're iterating at. Arrays are fast to index, but if I have to do it 4 or 5 times in this loop and there's 100 asteroids, it actually can be pretty slow. By doing this, I do this calculation only one time. I save the pointer. As long as we have the memory, it's faster. We have to remember that if an asteroid isn't active, we can just continue. Now I'm just going to get this collision out of the way. I can use check collision circles to provide 2 positions and the radii for each, and we can find out if those 2 circles are overlapping. If there was no collision between these, then we can just continue to the next asteroid. If we reach this part of the loop, then we've had a collision, and we know that at the end of this, we're going to want to brake. I'm not going to consider the cases where we can collide with multiple asteroids in this game. Instead, I'm thinking when we collide, we're going to take some damage. There's going to be a period of invincibility frames. What this means is if we were to collide with 2 asteroids on the same frame, once I've collided with one asteroid, I can break out of the loop. I don't need to compute if I've collided with any other asteroids because I'm going to be in a period of iframes anyway. By laying it out this way, I've realized that we actually need to have a more advanced player state. For now, I'm thinking that it'll be sufficient to have a normal state, as well as an iframe state and a death delay. The logic that's on the top here, taking damage, entering the state, and being nudged away, we can put this logic right here, because this is going to be the moment that we collide. The logic that's down here at the bottom for the iframe state, these are the things that are going to happen on the many frames after. So these are not going to be handled in the spot that we're at right now. To avoid bloating this any further, I'm going to go ahead and just write OnCollision, and we're going to write this as a separate function. I'm going to provide information on the asteroid as well. One thing I'm going to need to figure out is where the player is in relation to the asteroid so I know which way to nudge them. This is really easy to find, and we've done it before. If you subtract the asteroid position from the player position, we will get a line from the player to the asteroid. I want the line from the asteroid to the player, which is the one that I'm going to use to influence the velocity. I will say that we want to have this be normalized, so I'll just go ahead and do that here as well. Once we determine the nudge direction, I'm going to use vector2 scale to scale it up to the correct magnitude, and we're just going to go ahead and create this value. Once we've determined the nudge direction, I'm going to use vector2 scale to scale it up to the magnitude that we want, and I've just defined that as a const float here. So that should be the nudged away functionality implemented. The next one is we're going to want to take damage. For now, I'm just going to add an integer, and I'm going to set it to 3. I'm going to reduce the health, and if the health is less than or equal to 0, I'm going to create this onDeath function, and I'll leave it blank for now. That should be the taking damage taken care of, and now all we need is the iframe state. For now, I'm going to go with these. The player has a default state where they can do all of the normal interactions. The idea is that when the player is hit, they're going to enter the stun state, which is going to give them some time to just ride out that nudge velocity. Then they're going to enter the iframe state where they still can't collide, but at least they're able to move. Something that I've noticed is that this logic for controlling the firing is within player move. So I'm just going to pull that out. Okay, that was a little messier than I thought it would be, and the main reason for that was because there was some vital resources that were in the wrong places. Originally, update velocity was returning the player facing direction, so it needed to be used here. but I didn't see any reason that this couldn't be its own function, so I added that to player C. Don't forget to add it to the header. And then in here, I'm able to just reference it right inside of this function where it used to be. When we initialize the player, I'm going to make sure to initialize this new state field that I just added, which is corresponding with the enum. So now at the beginning of this OnCollision, I'm going to set the player's state to player stunned. In update angle, we don't want to do any of this if the player's state is stunned. For update velocity, for now, I'm also just going to make the entire thing skipped. Update wrapping, I'm going to always allow. And most importantly, this player position, as long as this is always preserved, we should be okay. So when we're stunned, we're basically not doing these things. In fact, for simplicity, I'm going to do it like this. These are kind of like our input functions anyway, so if the player's state is not stunned, we'll be allowed to do these. Just for fun, I'm also going to add that the player's state is not dead. I'm sure that when the player's dead, we're not going to want to let them move around. Aside from just tracking the state, we also need to know the time that we entered the state. To avoid this becoming a problem, I will add a player set state function. This is a really simple thing, but it's important that we make sure that the time state entered is always updated when we enter a state. Now in update player, if we are in the stunned state, we're just going to return. We're not going to do any of this other stuff. I will allow the player to shoot, but if we're still in the iframe state, we're going to return before we do any of the collision checking. Now in this new function tic_state, I'm just going to put in some timer logic. For now, I'm going to make the stun and iframe duration both 1/3 of a second. GetTime minus player.timeState entered will give us the number of seconds since we entered the state, and then I'm going to check if that is greater than the duration. If it is, we can change state again. In the iframe case, we're going to do the exact same thing, just with a different duration. And instead of entering the iframe case, we're going to go back to default. Going back to OnCollision for a second, we're going to check health absolutely first. And in the case of onDeath, I'm going to return. OnDeath, at the very least, is going to want to enter the player dead state. So in the cases where we didn't die, we will become stunned. Being stunned will eventually lead to us in the iframe state, which will eventually take us back to the default state. When it comes to player state machines, there are much more elegant approaches, especially in object-oriented languages. I'm not overly proud of this player state at this time, but as long as I can get it working, I'll be stoked. We've done a lot of stuff here, and just in the interest of testing, I'm going to make it so that the player color is going to report the state. When we're stunned, we'll use red. When we're in iframe, we'll use pink. And then when we're in any other state, we'll use white. Okay, so it seems like I died pretty good there, because I certainly can't move anymore. I'm going to crank this asteroid delay up quite a bit, just to try and reduce the difficulty. I think the nudge magnitude needs to be higher. I also feel like the asteroid should slow down. I think the asteroid is actually moving too fast. I'm going to change the OnCollision function to take an asteroid pointer instead, so we can use it as a reference. I'm going to start with a speed reduction of 0.6. After we set the state and set the player's nudge direction and velocity, I'll also reduce the asteroid's velocity using the vector2 scale function. I put 0.6 when I meant to put 0.4. I find that the health is a little bit too low for when I'm debugging. I'm still trying to try stuff out, so I'll just crank it up. I also think the time spent in the states is not nearly long enough, so I'm going to go to being a full second of iframes. Oh man, I don't know if it's the case that the asteroids are spawning too quick or if it's just not enough time to react, but yeah, that's rough. So I'm in the dead state now. That's why I'm just kind of floating. I can't move. I'm not decelerating at all. For the most part, the state transitions are working. I'm going to quickly draw up a health bar that we can use so that I can actually monitor our health. Okay, so a bunch of fiddling later, I added a draw health function to the new game UI file. Game UI needs to include game player and constants so that I can draw this health bar. There's a bunch of constant stuff at the top to give lots of configurability because my heart isn't set on any of this yet. We get the health from player health. We can build the rectangle that we use for the background of the health bar. Then we resize that rectangle to use it for the individual cells of the health bar, determine the color based on the value we're at, and then draw the bar. So you can see once I get down to half health, we go to yellow. And if I get even lower, we go to orange. I'll change that to red. I liked the idea of not using red, but I guess it's kind of the settled on answer. Just as some last minute tweaks here, I'm going to reduce the nudge magnitude again, now that we've changed how long the state lasts. I'm also going to reduce the stun state and increase the iframe, so it's still a full second, but now we're going to have more time where we can react. Now that I feel I understand how much time we're spending in each state, I don't want to use the state to change the color of the player anymore. However, I am going to make it so that the player kind of blinks to a semi-transparent color. If the player is in the iframe or stun state, I'm going to skip the stun state because it's so brief, but if the player is in the iframe state, I'm going to get the number of seconds that we've been in the state for. I'm going to put together a bit of a magic expression just to try and get a feel that I like. I think I've got something that I'm happy with here. So get the number of seconds since the state was entered. I scale it up by 6. So we'll get, about 5 flashes in total. On the frames where it's odd, so value mod 2 is going to give me, it's going to be true when it's odd, because value mod 2 will evaluate to 0 or 1. If it evaluates to 1, that's the same as true. And as such, this will be on the frames where it's odd. If I want the ones where it's even, I can check equality with 0. But on the frames where it is odd, we're going to set the color to a much faded white. And we just make sure to use that when we draw the character. As an alternative, you can also choose a red and then reduce how much it's being faded. I actually think I like that better, and I might just keep that. I'm going to go back in here and bring the player health max back down to 5. And in player.c, I'm going to make it so that we don't draw at all if we are dead. In tick state, I'm going to add another const float, which is going to be player death delay. I'll make it 1.5 seconds. And as with the other ones, I will add to the player dead case the timer for the player death delay. Except instead of setting state, we are going to say game over. First though, I just want to make sure that the player is no longer drawing when we die. In the state that our project has reached, it's got so much code in it, I finally understand. We're going to create yet another file, this one just called game.c. And of course, we need a game.h. Game.h is going to be dead simple. It's going to have an update and draw for the game itself. I will cut all of these and move them into game.c. I'm moving them because there's a little bit more state I want to add, and it's better to just put it in its own file. So now this is kind of the ultimate main file, because we include game, we init the game, update the game, and draw the game. Other than that, this is the file. It's literally just this one function. Cool thing about this is we don't need raymath or raygui anymore. There's a tiny problem here because we need these active asteroids and active projectiles, but I can also just make these static values and carry them over. Now, this probably isn't the prettiest, but what this is giving us is a really easy way from a top-down standpoint to see what each file is really doing. Files like asteroid, constants, debug, player, projectile, these don't have anything to do with the gameplay. They're game elements, yes, we need them for the game, but they're not the gameplay things. All of the gameplay things are in game.c and all of the other game underscore whatevers. I'm going to add one more option in here, which is game over. In game.c, I'm going to create an enum. For now, this should do. I'll have a main menu state, a playing state, and an over state. I'll create a game state just called state, and this can be static. And now we're going to need some static functions to manage that. Before I get to the switching states, let's look at draw game, since that's the most obvious change. All of these only happen in the game playing state, but I will allow asteroids to also be drawn from game over. Also, the nature of the debug menu is it's always accessible, so I'm going to do this after the switch statement entirely. In the case of the game over, I will just add a GUI button, which means we're going to need raygui. So when we're in the game over state, we will draw the asteroids, then there's a bunch of const information. We have a raygui button for the retry and a raygui button for quit. In either case, if we press one of these buttons, we set state, and I'm going to want to make sure to return after. I'm going to grab these consts and put them out here, partly because it's kind of ugly to have consts in a switch, I think, but also because I'm going to reuse these. Because we haven't used it in this project, I'm going to do it here. We're going to use an extern. It's kind of a hacky solution, but the idea is that in the main file we have a bool quit game. We add this to the condition for the loop. It defaults to false. From inside game.c I can have this extern bool quit game, and when we want to quit the game we can just set it to true. So we have state transitions to each state. Now we just need to implement them in this set state. Now we're going to need to add all of these different functions. When we're transitioning to the game playing state, we need to do all of this stuff. Basically, I'm going to want to look at each file's static fields and see which ones need to be reset. All the asteroids for sure, I want to reset those. The last asteroid creation time, I can afford to set back to -1, and the new asteroid base angle I can set to 0 as well. To reset the player, I basically want to do what's right here. So I'll just have this reset the player. And lastly, reset the projectiles. All right, now, so we've done a lot, and none of it's really been tested, so let's get these last couple states in here, and then we're going to want to do a big test. For the transition to main menu and game over, I can't really think of anything that I have to do. It's not a big game, so we're not going to unload anything. There's nothing that we load when entering the state in the first place, so I think we're okay to just leave this. Evidently not, since clicking asteroids doesn't seem to do anything. But quit works. That's something. Probably an important thing to do in set state is set the state to the state. Let's try that again. Let's go ahead and die. Okay, I'm not feeling that that's working properly. On death, we set the state to dead. That's right. We didn't actually uncomment this function. So we need to make sure that this thing is including game. Okay, that's working just fine. Quit doesn't work from this menu, but play again works. Okay, the health is not being reset, so we die instantly. Okay, that was silly. We didn't reset the health. That's fine. In game over, after we draw the asteroids, I'm just going to draw a black rectangle over the whole screen with a bit of a fade, just so that we can better see the UI that I'm going to add. After we draw that rectangle, I still want to draw the score, and it probably doesn't hurt to just draw a message here. I'll just move that game over down a little bit, and I want to reduce the padding between these buttons, and then I'd say I'm done. Okay, so here's what we've got. We've got a really simple menu. We can click this to play. The game starts. We can shoot the asteroids. It's maybe a little too easy now. If you die, there's a brief pause, and then it says game over. We can see the score. We can choose to play again. It'll reset the score and the health, and the game should just work. I can hit play again to play again, as we saw, or I can hit quit, and the game will close. So this part had a lot more content than I thought it was going to have. I thought we'd be able to get through this really simply, and there's still quite a bit left to do. For the most part, though, I'm going to say this project is done. There will be more videos in this series, and we will work on this code base a little bit more moving forward. All good things to come, but they're going to come in the future. I want to say if you really enjoyed this, please like the video, subscribe to the channel. You know there's going to be more raylib. If you have any neat ideas for projects that you think could fit into the scope of a few videos, please leave them down in the comments. And as always, I will see you next time.